Welcome back, guys. So this is the third lecture in trigonometry. Earlier we have covered the basics of trigonometry. We have covered what are the different functions, what are angles, how to convert them, some signs, and the domain, range, graphs, and we have covered the keys, basics of trigonometric functions, right? Now this lecture is very key. So this is the lecture from which you are going to get maximum questions in competitive exams, right? This is the lecture where we will cover the sum and differences of angles for trigonometric functions, right? Now, to start with, this lecture we have to go with what are the values of sine of minus x and cos of minus x, right? So for this, to understand this, we have to understand this line, okay? Now, this is the coordinate axis, and there are angles which are going to lie here, right? So these are going to be some angles here. Now, if I see what are negative angles, so when we move clockwise direction, it's like negative angles. When we move in anti-clockwise direction, we have positive angles, right? Now, what happens is, if I start moving at this point and I stop here, right? So this is one angle. Now, what happens is this is angle x. Suppose this is angle x, right? So what is going to be the negative angle of this? It's simply the image of this, whatever I am going to get on the top, it's the image on the x-axis. So if this is 1, this is axis, then this is negative x, right? Likewise, if I go here and then I complete cover this point, right? So, sorry, if I cover this much amount, so I am here, right? So I said I have to take the image of this. What's the image of this in the x-axis? It's going to be like this, right? So this is the image. So this is negative x. So if this is alpha, then this angle is minus alpha, right? So essentially what we are doing is, when we speak of negative x-axis, we are negative x angle, then we are essentially taking the image in x-axis, right? That's all. Now, we have to see, x is the sine, sine x is the y coordinate of any point on the circle, right? Now what happens is, we see that, sine toggles between these two, across this x-axis. So sine is positive here and negative here, right? So the moment I am speaking of x, I have some value, be it positive or negative, right? So it could be positive here or it's negative here. If x lies here, then it's negative, sine is negative. If x lies here, sine is positive, right? So the moment I take for sine of negative minus x, so I am taking the image of the x here. So I am going to toggle the the sine. So in that case, sine x has to be equal to sine of minus x, right? Minus tan sine of x. Because what it's doing is essentially toggling the sign, right? That's one. Now, for cos of minus x. Now let's see cos. Cos, what happens is, it toggles signs across y-axis. It's positive here, it's negative here, right? So it's positive here, cos, right, and negative here. Now, if x lies here, cos lies here. If cos is positive here, cos remains positive here, even after taking minus x. Likewise, if cos x lies here or here, after toggling across x, x and minus x lies here, and cos is negative here. So cos will not change sign. So cos of minus x has to be cos of x, right? So these are the two things that we have to remember. These are key fact, for sum and differences of angles. We have to remember this, that cos of minus x is minus tan cos of x, and cos of minus x is cos of x, and we have to remember this image, right? Why it is so, right? Now we have to derive one key formula, which is going to be the the main, I will say, concept that will define the remaining sum and differences of trigonometry, right? Now for that, what I have to do is I have to draw an image. Okay, so first of all, let's draw a big circle. Okay, now this is a big circle. Okay, let's define the origin here. Let's draw the coordinate axis, right? Okay. Okay, now this is the coordinate axis, right? Let me take another marker. Okay, so I defined 4 points. P1, let's define it like P2, a point here, P2, and let's define a point here like P3. And then, okay, so what happens is, what I'm interested in, if I know, I am interested in cos of x plus y. So my point is, if I know cos x, x is an angle, y is an angle, right? So let's say this angle, okay, this angle. This angle is x. Let's say. First of all, let's define the coordinate. It's 1, 0. This is origin. So this is 1, 0. It's a unit circle, right? Now here, what's going to be the coordinate of this point? I know it's an angle of x, so x-axis is cos x and y is sin x, right? This is pretty simple, right? Now, what I'm saying is, from here I'm drawing another angle from x. I'm saying this is y, right? I'm calling it as y. So what I'm doing is I'm interested in cos of x plus y, that is cos of entire thing. I know this is x, this is y, and I'm interested in this. What is going to be the coordinate of this cos of x plus y, comma, sine of x plus y? This is fine, right? This is the coordinate of this point, right? Now what I'm going to do is, I'm going to draw another point here, which is nothing but almost like, this much amount, which is like y in negative direction, right? So I'm going to draw a point here. Suppose here, right? So let's call it as P4. Okay. So what is this angle? This is minus y. What's the coordinate here? Cos of minus y and sine of minus y, right? So these are the coordinates. Okay. Now that the image is there. Now what we are going to do is we are going to look into two circles. First, this circle. This circle, and then I am going to look into this circle. I'm sorry. This is not circle, triangles. I am going to look into two triangles. So what are those two triangles? Let's call it O. So what are the two triangles I am looking at? The two triangles are this O, P2 and P4. Triangle O, P2, P4 and triangle O, P3, P1, right? Okay. So we are looking into these triangles. This one. This is one. I hope it's clearly visible. And this is the second triangle. And so we are looking into these two triangles. Okay. Now, let's say this length is equal to this length, and this length is equal to this length. Those are radius, right? This angle is y, this angle is y, this angle is common. So this obtuse angle of the triangle is also same, right? So this angle is common, right? So let's see this angle is y plus alpha, right? And this angle is also y plus alpha, right? So these triangles are congruent. I will say these triangles are congruent. Okay? This is the 10th class topic. So since these points are congruent, then I know that this length of this chord is equal to length of this chord. So by congruency, I say length of P1, P3 is equal to length of P2, P4, right? And I know the coordinate, so I know the formula. So what's the formula of distance between 2 points x1 y1 and x2 y2? It's very simple. It's x1 minus x2 whole square plus y1 minus y2 whole square, right? And under root of everything, right? So this is the coordinate formula, distance formula using coordinates. So now what I am going to do is I am going to find distances using the coordinates that I have with me. These are the coordinates that I have with me, and I will try to equate it, right? So first of all, what I am going to do is let's calculate the distance. I will try to use this part and that part. So I am calculating P1, P3, right? So what's P1, P3? It's cos x plus y minus 1. Cos of x plus y minus 1 whole square plus sin x plus y minus 0 whole square, that is sin of x plus y whole square, right? So what I do is cos square plus sin square, that makes 1. So I put 1 plus b square, that is 1, minus 2 cos x minus 2ab, that is minus 2 cos x plus y, right? I hope you are able to understand. This sin square and this cos square becomes 1. This 1 remains 1 here, and minus 2ab gives me this. So this is the distance. Now I am going to find P2, P4, right? What is P2, P4? So P2, P4 is nothing but cos x minus cos y. So it is cos x minus cos of minus y whole square plus sin x minus sine of minus y whole square, right? Okay, yeah, that's all. So now I know cos of minus y is y, I remove this, and sine of minus y is minus y, I make it as plus, right? Now let's square. Cos square, sine square will give me 1. Cos y plus sine y will give me 1. I will get 2 ones, and here I get minus 2 cos x cos y from this, and from here I get 2 sin x sin y. Right? Now these two things are equal. Right? So if these two things are equal, what I do is I remove this, I remove this. Okay? I am done with this, I am done with this. Right? So what I am left with is, like essentially I am moving it here. So removing the minus sign as well, so it becomes negative, it becomes positive, and this becomes negative, right? So what I get is, and I essentially remove the 2 as well, right? I remove the 2 as well. So what I get is cos x plus y is equal to cos x cos y minus sin x sin y, right? Right? So this is a key formula that we have to remember, right? So this is what we have derived. Again repeating, that's fairly easy. We took like an x, we took like an y. So we are interested in x plus y, we are interested in the coordinate of this point. I know the coordinate of this point, so what I do is I took another point y, not here, I took it in the negative y direction. I could have taken y here as well, but I took it in negative direction. Found two triangles which are congruent, equated the length of the arc or length of the chords, and we exactly got the formula for cos x plus y in terms of cos x, cos y, sin x, sin y, right? So this is one formula that we have to remember, right? So let me remove this. Okay. Now what happens? This is a key formula now. Okay. Let me write it again. So what we have proved is, we have proved cos of x plus y is equal to cos of x cos of y minus times sine of x sine of y, right? Now from here what we can do is, we can easily find cos of x minus y, right? It's fairly easy. What we are going to do is simply replace y with minus y. So I get cos x remains same. Cos of minus y becomes cos of y. That's fine, right? Sine of x remains sine of x, right? And sine of y is now sine of minus y, which comes with a negative sign, becomes plus, and which becomes sine y. So sign changes here. So when I make it sign negative, it becomes positive, right? So that's another formula, right? Now let's say I am looking into cos of pi by 2 minus x, right? So this is what, this is cos a minus b. Let's write it. So it's cos of x, which is cos of pi by 2. I know cos of pi by 2 is 0, so this goes away. And here I am left with sine of x, which is sine pi by 2 into sine of y. So this is minus times sine of x, right? Okay. So this is not minus, so this is a minus b, so this is b, right? So this is b. So what happens is cos pi by 2 is 0, so this goes away. Sin pi by 2 is 1, and sine of x is sine of x. So minus sign is taken care. So this formula itself is like this, right? So it becomes sin x. And either case we know, like it's pi by 2 minus x. Pi by 2 is here. I'm subtracting something here, so I'm essentially moving in first quadrant. This is a thumb rule that you can use to recall, right? So thumb rule says, like if I am moving from pi by 2 minus x, so let's assume x is very acute number. So if it has to follow a rule, then x can be a very acute number. So it has to fall in first quadrant. It has to be positive, right? It has to come with a positive sign because cos is positive there, right? Okay. Now what happens is, when we have something from pi by 2 minus something, right? It essentially becomes sine, so it toggles. Cos becomes a sine and sine becomes a cos. Likewise is with pi by 2 plus x, right? So whenever we have some pi by 2 plus minus x sort of situation, cos becomes sine and sine becomes cos, and the sine is decided by like which quadrant are we going to fall, and what is the value of quadrant of that function in the quadrant, right? I will show the examples. Now Likewise, what we can do is, let's do for sine of pi by 2 minus x, right? We will do it in two ways, pi by 2 minus x, right? Now first of all, let's say, if pi by 2 minus x, I know the function is going to toggle, so sine has to become cos, right? First thing. Now sine pi by 2 minus, so pi by 2 minus is going to fall in first quadrant, and sine is positive here, it has to be positive here, and it's going to be x. So I know this is cos x, right? So that's one, right? Okay. Now, since we know this, let's do it for, let's try to find the formula for sine x plus y, right? Let's try to find it. So this is nothing but, when we have to find sine of x plus y, I know this is nothing but cos of pi by 2 minus x, so that I can say this thing is, let's say, alpha. So I will say this is nothing but cos pi by 2 minus alpha, right? Cos pi by 2 minus alpha give me sine alpha. It's here. Now what is alpha? Let's replace. Alpha is x minus y here, right? So this is the situation. Cos pi by 2 minus x minus y, right? So let's take it in this way, is equal to cos of pi by 2 minus x minus y, right? So let's take it in this way. So now it becomes cos a minus b sort of a situation. I make it cos a, cos pi by 2 minus x cos a, cos b, plus sin a, sin pi by 2 minus x sin y, right? Okay. Now I know cos pi by 2 minus x. What is sin x? Is equal to sin x cos phi plus sin pi by 2 minus x is cos x plus cos x sin y, right? This becomes another identity. This is very important. This is the formula for sin x plus y now, right? So now this is the formula for sin x plus y, right? Okay. Now since we have, so I am deleting this part. Okay. So since we have the formula for sin x plus y, let's write the formula for sin x minus y. Sin x minus y, right? So what is sin x minus y? Let's replace y with minus y. So cos minus y is cos y. So it remains sin x remains sin x, and cos y remains cos y, because cos y is equal to cos minus y. Cos x remains cos x, no issues here. But now sin y becomes minus sin y. So this becomes minus and it becomes sin y, right? So the formula toggles. The sign here toggles, right? Okay. So these are the two formulas for sin a plus b and sin a minus b, right? Now the thing that I told you that, okay, on pi by 2 plus minus something the function changes. However, on pi plus minus something the function does not change, right? So if I am doing sine of pi plus minus something, it remains sine, and the sign is decided by the quadrant in which I am going to form, right? Quickly I will show you some example which I want to say. Cos of pi by 2 plus x, right? Let's go by the rule. We are doing pi by 2 plus something. So first of all I know it's going to be sine, right? Let's make it sine. Now it's pi by 2 plus something. Let's make x very acute. I am going to fall in second quadrant. Cos is negative here, so make it negative, and that's going to be minus of sin x, right? Correct. Now next is, say suppose sin of pi by 2 plus x. Again it's going to be cos. Okay, pi by 2 plus in second quadrant. In second quadrant sin is positive, it's going to be positive. It's going to be cos x. Sin pi by 2 plus x is cos x. Cos of pi minus x. Cos of pi minus x. Now I said when it is pi plus minus something, the function does not change. So it's going to be cos again, right? Now pi minus. So pi is 180. I am subtracting something. I am falling in second quadrant. Cos is negative in second quadrant. It's going to be minus cos of x, right? Likewise, sin of pi minus x. Now here again it's pi, so sin is sin pi minus x, second quadrant, sin is positive, positive, so sin pi minus x is sin x, right? Likewise, let's do it for cos of pi plus x, right? Cos of pi plus x. So it's pi plus x, since this pi, cos is going to remain as cos. Now this is third quadrant, 180 plus something. Third quadrant cos is negative, so let it be negative, and it is cos of x minus cos of x. Then sin pi plus x. Now sin pi plus x, I know it's going to be sin and sine is going to third quadrant, sine is negative, so it's minus sine of x. Okay, now cos of 2 pi minus x, right? So 2 pi minus x, I know pi and 2 pi, the cos remains the cos, so it's cos x. Okay, it's going to be 2 pi, 360 minus something is going to fall in fourth quadrant, cos is positive here, it's going to be positive, so that's fine, that's absolutely fine. Now sine of 2 pi minus x, since it's 2 pi, sine will remain sine, and fourth quadrant, it is sine is negative, so this is minus sine of x, right? So now these are something that you can easily do. The moment we have this, we know what is going to be tan of 5 plus x. Tan of 5 plus x is nothing but sine of x divided by minus cos of x is going to be negative tan x. So all these things now we can find once we have these things derived, right? So that's one. Okay. So let's stop here. Let's take a small pause. So what I'm going to do is, this is one part of the lecture that we have covered of basic functions. Now the next part, which is going to continue in the same direction, that is the sum and differences of angles for of trigonometric functions. In that we are going to cover tan x and cot x and further some more things, right? So let's stop here, and guys, please keep looking into the next video for this. That is going to be the end lecture for sum and differences, and the last lecture is going to be trigonometric equations. Okay, thanks.